transformation matrix. HTM simply describes the position vectors and the rotation matrices of a mechanical manipulator. Position vectors are used to determine the displacement of a reference frame and a projected frame, while rotation matrices determine the orientation. The image that is shown or presented shows how position vectors and rotation matrix are made into equation. These two. By combining these two, will result into a homogeneous transformation matrix like this. Note that the first 3 by 3 matrix is the rotation matrix here, while the last 3 by 1 matrix is the position vector here. Added with an augmentation column, we can make a square matrix. This is the augmentation column. For the next part, we will show the homogeneous transformation matrices for each frame in a spherical manipulator using another homogeneous transformation matrix. Replacing this table with the variables of our DH parametric table for spherical manipulator will turn into this. This is our DH parametric table, and this is the homogeneous transformation matrix with the replacement of our DH parametric table. So now we will start by formulating the HTM for H01. For now, I will show you the full HTM for H01, and after we will discuss on how we formulate it. So here, you can see that the cosine theta sub n turned into cosine theta sub 1 because according to our DH parametric table, our theta 1 value is just theta 1. The same goes for the other formulas in the HTM because we just replace all the variables with a subscript n with values that will be taken from the DH parametric table. By that principle, this will be the results. So here, such as for any values with cosine alpha n, it becomes 0 because cosine 90 degrees is just equal to 0 since alpha sub 1 is 90 in our table. And in contrast, sine 90 degrees is 1. That's why sine theta 1 and negative cosine theta 1 here remains. And then here, for our last column that has r sub n, it becomes 0 since all the r values in our parametric table is 0. And then we put the value of d sub n in this row, which is a sub 1 in our parametric table. Applying the same things in our next two HTMs, which are H12 and H23, we get this. So here, in our H12, our theta value, theta sub 2 is 90 plus theta 2. So that means every theta sub n in H12 is this value. Next is the H23, wherein our theta sub n values are or is 0 and Cosine 0 is 1 and sine 0 is 0, which explain why there are no more cosine and sine equation in H23, since they are either 0 or 1. And notably, our d value is a sub 2 plus a sub 3 plus d sub 3 based on our table.